Hi, welcome to my next tutorial in Houdini. In this tutorial, I would like to give you a introduction onto the rigid body objects and the rigid body solver of Houdini. I'll show you the finished output first. In our lesson today, we are going to learn how to make a scene where there are a lot of coins which are falling down. Okay, so this is a completely rigid body network. You can see there is a random rotation as well as there is certain angular velocity and a bounce which has been added to this scene. We'll also be working with a basic expressions in Houdini on how to randomize these movements and how to randomize these simulations. Alright, with that said, I'll just stop this. I'm going to take a new file here. We'll start the scene right from scratch. So first and foremost, I'm going to just make the coin. It's a very simple setup. I'm going to take control left click on the circle object and probably rotate it 90 degrees so that it's flat onto the scene, and I'm going to change this. I'll just open up my network. Alt Shift W is the shortcut for opening up your network. I'm going to double click on this. This is my circle object. Go inside the geometry. Now primitive type, I'm going to set it to polygon because I would like to extrude this, and I'll just increase the divisions so that they are slightly smoother here. With that selected, I'll come to polygons and poly extrude. I'm going to move this upwards so that it takes a slight depth here. It's empty on this side. All you have to do is come to options and switch on output back so that I get a solid object here. Now this is where I'll finish off with the coin. I'm not going to go much into a detail of this modeling. There are already basic polygon modeling lessons which has been given out. If you are not able to understand how this polygon extrusions take place, please go through the lesson in which introduction to polygon modeling in Houdini was given. Now I've got this coin object here. I need to reduce the radius of my coin object. This is an unnecessary comment. Yeah. So let me just go inside my circle object. As you can see, my network shows the circle which I had taken first as well as the poly extrude 1. So I click on my circle here, and right now my radius is 1 and 1. I'm going to set this to 0.4 by 0.4, slightly more smaller, right? So with that done, let me come back to my object level. Here, right? So now I can start with the rigid body. Now I can start with my rigid body simulation with this circle object. I'm going to just rename this to coin. With my coin object selected, I'm going to come to my rigid body panel here. Okay, and the first option here you've got is creates an RBD object from SOP geometry. Simply what this means is it's going to take a geometry object and it is going to convert it into a rigid body object. So with this circle selected, with this coin selected, I'm going to click on RBD object. Now it takes a couple of seconds to cook out, and here since I'm going to work with a rigid body object, there is automatically an autodop network that has been added. Whenever you take a rigid body object, an autodop network is added. This has already been explained in the previous lessons where we have shown you how to fracture a crystal ball, where we have used Voronoi fractures as well as rigid body objects. So anyways, coming back to this lesson, double clicking on this autodop network takes us inside. So I'll press L to bring in the entire network onto my scene. You can see I've got my coin object first, then I'm going to merge this coin object to a rigid body solver, and finally that rigid body solver is again merged via a gravity. Now click on this coin here and let us see the properties that we have. You've got position, you've got rotation, velocity, angular velocity. We're going to keep these more or less, but we're going to change the position, rotation as we go ahead. Creation frame and number of objects. Basically what number of objects means is how many objects that you want onto the scene. You can have multiple copies of the same coin object. At the same time, creation frame is, it tells you in which frame the new rigid body object is going to get created. first and foremost, since my coins are going to fall, I'm going to take this up to a height of 15. Okay, so 15 is a bit too high. Let's take this to some other 8 or something. That's better. So I've got these coins here, and I'm going to quickly add a ground plane. Okay, so that it collides. Now I have not made any changes to the scene. Let me just play this simulation and see what we have here. Yes, you can see that the coin falls down, flips over, and settles down. There's a bounce in the scene, which is giving it a lot of free movement here. Now this is basically one coin dropping onto a collision plane, but we want more than that. Let me come back to my coin object here. Yeah, so I want more than that. Now here you can see it says creation frame is 1. Now we can add a small expression here which will tell us that at which frame we want this to work. Like for example, if I look at this frames, now I am going from 1 to 240. Let us say I want a coin to be generated at every 10 frames. So how do we do that? So I'm just going to come here and I'll write if $f. $f is basically your current frame, current whole frame. For example, if I've got a current frame to be at 1.56, it will return 2. So current frame is $f. If $f is modulus of 10, that means if I divide the current frame by 10, the remainder which I get, that is what $f modulus 10 is going to return, is equal to 0. That means if my $f is a multiple of 10, that is what I am checking. If my $f is a multiple of 10, then let me take $ff. $ff is float frame. That is 1.56 is the current frame number. It will take 1.56. So $ff else, if the condition is not true, 0. I'm going to read this out. Float, if this is my expression, float expression, if $f modulus 10 is equal to 0, if the remainder of the current frame divided by 10 is 0, then take the current float frame, that is $ff, comma 0. That is my expression. So I'll just close this and hit an enter. Let's rewind this and see what we get. Now you can see at a multiple of every 10 frames, my coins are falling, right? So right now what is happening is, if like again at a multiple of 10 frames, right? So at 240 frames I've got 24 coins. Now if you want to increase this, you can always increase the number of coins that are falling onto your scene. Just change this from multiple of 10 to multiple of 5. It will double, right? So let's rewind this and play. So now I am getting a coin which is falling every 5 frames. Okay, the frequency has increased. So I can even see that it's kind of stacking up over here. But obviously the gravity will continue its effect on these coins so that they kind of settle down after some time. So this is how we are making a heap of coins here using a simple expression where every 5 frames a coin is getting added to the scene. Okay, now this kind of is pretty much held on to it. Alright, now what we need to do is we can again change this. Instead of 5 frames, you can make it 8 frames. It's again your how you are going to settle these down. Okay, simply changing this factor is going to increase the number of coins that are getting emitted or rather getting spawned onto the scene. Okay, so this is what we have. Now obviously a scene right now all my coins are getting emitted from one point. Okay, because the x position and the y position and the z position is set to 0 and 0. So on the xz plane it is at 0. So I'm getting a stack. It's an 8 stack. That's fair enough. But sometimes your scene might demand that the coins they should be spread across. They should not be getting emitted from one point, or rather it should be spread across a plane, or spread across a grid. So in that situations, what do you do? What we'll do here is we will just add an expression to position x and position z, which will randomize these positions. So how do we do this? Obviously I'm going to randomize, so I'm going to need my random object, and whenever we give a random object, we need to give it a seed value, right? So best, or rather the easiest way of giving a seed value is using an obj. Just take an object from the scene as its seed value. Now obviously I don't want this to take a huge, take any random number which is not going to fix onto my scene. So I need to limit my random. By, let's say I need to limit it between -1 and +1. Because why I'm saying -1 and +1, let's just understand this. Let's understand why I'm saying -1 and +1. See, this is 0. This is 0. Let's say a 0. I'm talking about x. This is 0 on x. So if this is 0 on x, so this is probably the positive side of x, and this is the negative side of x. So if I want it to cover this entire length, I should be covering up both the negative as well as the positive side of x. So I'm going to do that using the same. I'm going to write obj, and I'm going to limit this. How do I limit an object? Limit a value. I say fit 0 1 bracket random of obj, comma, I'm going to fit this random of obj between -1 and +1. Okay, but again between -x and -1x and +1x, the distance is too less. So I need to give it an offset. Right now the distance is going to be too less, because -1x. See, if I play this also right now, it hardly makes any difference, because -1x and +1x, there's not much of a gapping, right? So how do we change that? We are going to simply offset this value. Let's multiply this by 10. Let me rewind this now and let's play. So right now we have offsetted it on x, right? I think I've probably moved my object by mistake. Let's just check this. Fit 0 1 and okay, that's fine. Alright. Now I would like to give the same value over here also. So I'm going to give fit 0 1 of random of $obj, but this time I'm going to change the seed. I'm going to give it into multiply into 5, so that the next set of random values don't remain the same. Comma -1 comma +1 into 10. Let's start this and let us play now. So right now I should be getting it on randomly on all across the plane. It's no longer only on x and y. They are taking it on different areas altogether. Alright, -1 +1 into 10. Yeah, fine, that's done. Now obviously I would like to give it some rotation also, right? Some angular velocity. So I'm going to use the same expression. It's just that I'll just change this obj factor here. I'm going to change this obj factor here. Instead of into 3 or into 5, I'll probably take into 10, and I'm going to probably shoot this up to somewhere around 30 for the angular velocity of x. I'm going to copy this and put the same thing onto the angular velocity of z, and here we'll take into 9 and into 30. So I've got a different. Sorry, it's cooking for a minute. Yeah, let me just rewind this now and play. You can see there's an angular velocity here. The coins start tilting as soon as they start falling, because it gives you a more realistic approach towards this. See, again, you can randomize this as much as you want. You can keep changing. If you want more, again, coins, change this to 5 or something, so the number of coins are more. So this is how, using our basic expressions, we were able to generate as many rigid bodies as we wanted onto a ground plane. This is a small introduction to how our rigid bodies work in Houdini. That would be all for this lesson. Would appreciate feedbacks from your end. Thank you very much.